Hi, everyone. My name is Raúl Fernández-Díaz, and I'm an industrial PhD student at IBM and University College Dublin. I'm here to present our work on AutoPeptideML, which is an open source library for democratizing peptide machine learning. I wanted to thank the organizing committee for giving me the opportunity to share my work with you today, and all the co-authors that have made it possible. With this, what is AutoPeptideML? I've been saying that it's a democratizing peptide machine learning, but what do I mean by this? The idea is to enable or empower experimental scientists to be able to build their own machine learning models from their experimental data, so that they can integrate them easily and quickly into their experimental workflow, so that the model predictions help inform the next set of experiments, and that set of experiments helps improve the model. There are two types of peptides that I'd like to introduce to you so that to follow the rest of the presentation. They are the natural peptides, which are small protein sequences that are, from an experimental point of view, really cheap to manufacture. So most of the experiments will be done with natural peptides. On the other hand, we have the synthetic peptides, which are more expensive, but they have better pharmacological properties and are better drug candidates. So the first version of AutoPeptideML was built to work with natural peptides just because they are more abundant. And we are extending now support to synthetic peptides and peptidomimetics. And the reason why we are doing this extension, which is a fairly substantial amount of work, is because we had this hypothesis or this idea on how to build more effective models. The idea is that natural peptides are really easy to get data from. So what if we train models using AutoPeptideML on those natural peptides, and then use those models to predict the more expensive experiments so as to prioritize the most promising candidates? And from a bit of a computational point of view, this entails refactoring the whole pipeline so that it not only works with natural peptides, which were sequences, but also with synthetic peptides, which are molecular graphs. So we need to have a robust pipeline that can interconvert between sequences and molecular graphs. And because we are assuming that the user doesn't have the computational knowledge to perhaps create multiple files or to homogenize it themselves, we accept a list of sequences or SMILES, and then everything will get assigned automatically. We also handle the different steps of the machine learning process, but I will not get into the technical details of that. Finally, with regards to this hypothesis of training on the natural peptides and then making predictions to synthetic peptides, we evaluated it in 4 different tasks related to drug discovery, like prediction of different types of antimicrobials or cell penetration. And our conclusion is that, yes, it is possible to do this kind of extrapolation. There is less model performance takes a hit when compared to just interpolation, where you are training on natural and predicting natural, or training synthetic and predicting synthetic. Performance drops like by half, but you still can get a reliable model. One of the most interesting things that we found is that despite new techniques like language models for proteins, peptides, or small molecules, the more traditional chemoinformatics approaches, just fingerprints, been there for 30 years for database searches, are better for this extrapolation scenario. Finally, 4 takeaway messages that I want to share with you are, first, that AutoPeptideML exists, and that its main goal is to empower experimental scientists to build their own models. Second, that the latest release supports also synthetic peptides and peptidomimetics. Third, that we have command line interface and web server to facilitate access and compliance with FAIR principles or the DOM guidelines that Gavin talked about in the previous talk. And finally, that the whole aim is to reduce the experimental costs. With this, the lightning talk is kind of short, so if anyone is interested in any of the topics, please feel free to reach out. Thanks for your attention.